All right, everybody. So today what we're going to be looking at is section 1.3 in our textbook, which is all about solving equations when we have special cases. So there are three different types of solutions we can have, either always, sometimes, or never. So go ahead and take a moment, pause this video, and write down these boxes, and then I will talk about what they mean. Oops. All right, so the first type, always. This is when no matter what value we plug in for our variable, so if we're solving for x or y, whatever our variable is, no matter what we plug in, it will always, always, always be true. It works for everything. The way we identify this is saying we have infinitely many solutions. Now, the next case is when a number is sometimes true. So this means it is true for some values of the variable, not everything, but some. So for linear equations, this means that it has one solution. So for example, this would be when you get an actual value as your answer. So for example, this would be if you get an actual number. Say you get x equals 4. You get a number for your answer. Now the last case is when it is never, which means it is not true for any value. So no matter what number you try to plug into your equation, you will never find something that works, never something that is true. When this happens, we say that it has no solution. All right, so let's look at some examples of this. I'm going to scoot this down a little bit. Go ahead and take a moment, pause your video to write down your first example, or all three if you want to write them all down. All right, so let's look at the first example. So if I have this 1/2 on the outside of the parentheses, I'm going to follow the same steps from last week, the last lesson, where I distribute that 1/2 to everything inside of my parentheses. So 1/2 times 6, half of the number 6 is 3, so 3x. And then half of the number 4 is 2, so 3x minus 2 equals negative 5x plus 1. Now, I don't have anything that I need to clean up, so I'm going to go ahead and isolate my variable. I want to move all of my x values over to the left, so I'm going to add 5x to both sides. You could have chosen to subtract 3x instead. So I end up with 8x minus 2 equals 1. Now I want to get that 8x by itself, so I'm going to add 2 to both sides. And I end up with 8x equals 3. And then my last step is to divide both sides by 8. So I end up with x equals 3 over 8. So this is an example of when we have one solution. So I'm going to go ahead and write that on here. We have one solution. Because we got an actual value for our answer. All right, let's go ahead and try the second example. If you need a moment to write it down, go ahead and push pause. So the first thing I'm going to do is distribute this 3 to everything inside my parentheses. So 3 times 5x is 15x. 3 times 2 is 6 equals 15x. Now, if I want to get all of my x's together on one side, I'm going to subtract 15x from both sides. But when we do that, the x's over here cancel and the x's over here cancel. We're left with just 6 equals 0. That is not a true statement. That is a false statement, which means there is no value of x that I could plug in that would work for this equation. We have no solution. All right, now the last example. Go ahead and pause this video and take a second to write it down if you need to. The first thing we're going to do is distribute this negative 2 to everything inside of the parentheses. So negative 2 times 4x is negative 8x. Negative 2 times 1 is negative 2 equals negative 8x minus 2. Now you may notice right now, your left side and right side of the equal sign are exactly the same. They are identical. Now what that means is if I were going to try to get my x values on the same side together, I would add 8x to both sides. All of my x values cancel out, and all I'm left with is negative 2 equals negative 2. That's a true statement, which means no matter what I plug in for my value of x, I could plug in any value I want, it will always be true. So my answer is infinite solutions. I'm going to add a little note here to go with these as well. This was a true statement, whereas the example above this was a false statement. Sorry, my fan keeps blowing the corner of my paper up. All right, so what we're going to do next, let's flip the page. You are going to try a few examples on your own. So go ahead and push pause. You can write this down. I'm going to pause my screen recording so that I can fill in the answers to this. I'm going to try to pause my screen recording. Where is the button for it? Oh, here we go. Okay, I'm going to pause my screen recording and I will fill in the answers. So when you are done checking this, you're going to push play on the video. All right, now that you've had some time to try these problems on your own, I wanted you to go ahead and see the solutions so you can double check your answers to see if you are on the right track. You can pause this video if you need to view these longer, but that is the end of our notes. Have a nice rest of your day.